Hey guys, welcome back to another video. Today we're going to be trying to solve another UKMT question. So this is a question. The diagram shows a square, a diagonal and a line joining a vertex to the midpoint of a side. What is the ratio of area P to area Q? So to make it easier for ourselves, we'll draw the diagram again, adding some few sides to help us figure out lengths and stuff. So we have our square, and then in our square we know we have our diagonals, and then we know the point, and then we know that there is a line that goes from the midpoint of a side to the vertex of a side. And then we can label each side a different letter, so we have A, J, L and K. And then we can draw a line that crosses the intersection, and then we can call that, and we can call both sides, so from there to there, call this point R, and we can call this point S, and we can call this point M, we can call this point N, so the intersection is N, and then we can draw a perpendicular from N to the foot of the side, and then we can call that T. And this is our full diagram. So the reason why I did this is because we can find, we want to find out the area of this triangle, and this triangle, and this triangle to find the area of Q, basically. So then we can add the triangles of this P and that, and then subtract it by the area of the whole square. So, what we can do to find the area of these two, we need to prove that these two triangles are similar. So we prove that they are similar because first they have opposite angles, so in this intersection here. So opposite angles we know are similar, so that's point 1, so opposite are similar. And then we also know that because this from I to K, it's a diagonal, so therefore, and I to L and J to K are parallel, therefore this angle here and this angle and this angle here are alternate, so therefore these are the same as well. Right, so we know that two angles in both of these triangles are the same, therefore the third angle will also be the same, therefore the two triangles are similar. Now, because we know that both angles in these triangles are similar, we can actually find out all the lengths from that. Okay, so we know that from I to L, because we don't know the length of this side, it is best to call this the length 1, as in this, and we know that MK, because we know it's from the midpoint of the side, that would have to be half. So that means the ratio of I to L over M to K would just be 2, basically. So IL is double of MK. So therefore, from IN, so from this side to this side, that would also be, so NK would be half of IN, so we know that IN to NK would also be 2. And then, because we know that, we can also use this with the height, so our line from R to S. So we know that from R to N and from N to S, RN would have to be double of NS. So when you're trying to divide a side into two, with one part being double the size of the other side, we would do like a third and then 2/3, and we know that a third plus 1/3 is 3/3, so that's 1 anyway. So we have 2/3 and 1/3, which are the areas of lengths of those sides. Now we've got that. Now we have to, we want to prove that NKTS, so we want to prove that NKTS is a square, so that we can prove that NT, so NT is equals to NS. So we know this because along a diagonal in a square, wherever you can always, whenever you mark out a shape, it's always going to be a square, and then we know that from NS, if that is a third, from NS, if that is a third, then from NT that would also be a third. So we've got that. So now we know all the lengths of all the sides of the triangle, so now we can find out the areas of all of them. So to make it easier, we'll just draw out each one. So for the area of LNK, so for the area of LNK, so we have N here and K here, we have, you obviously do half times base times height. So half times the base, which we know is 1 because it goes along the whole, times the height, which we figured out, which is basically NT, which we know is a third. So that equals 1/6. So that's the area of LNK. Then we have the area of INL, which is this one. So INL, which is half times its base, which we know is 1 because it's the side, times 2/3, because we know from here to here, we figured out that this was double of N to S, so that would be 2/3, which we know is a third. Got that. And then our last area, which is MNK, so that's from this one to there to there. So you have K, we have M, and you have N there. So that would be half times its base, which we know is half, because MK is half of the midpoint, times a third, which we know is from N to S, which is a third. So that equals a 12th. So now we have the areas of all these triangles. We can add these areas up. So we basically had a 6th plus a third plus a 12th. And then we could just make the denominators the same. So you have 2/12, 4/12, plus 1/12, which is 7/12. And then to minus this number from the area of the whole square. So the area of the whole square is basically 1 by 1, which is also the same as 12/12 to make it easier. So 12/12 minus 7/12 would be 5/12. So 5/12 is the area of Q. So the area of this shape here, Q. And now we know the area of Q, and we know the area of P, which was basically NLK. It's basically LNK. So this one, because that's the same as this one here. Then you do, so if it's the ratio from P to Q, then it's basically 1/6 to 5/12. So you can make the denominators the same, so 2/6 to 5/12, 2/12 to 5/12, and then the over 12 cancels out, and then you just have 2/5. So that is the ratio of P to Q. Thank you for watching today's video. Please make sure to like, comment, and subscribe. We'll see you next time.